Good evening, everyone. So this is our talk about the Malware Must Die's team effort in dissecting the Kelios Fast Flux botnet. This will be like a quite an exhaustive research presentation. So my name is Dhia from OpenDNS.
I'm Hendrik, Adrian, the founder of the Malware Must Die.
So this is the outline of our talk. Part one will basically describe the monitoring of the Fast Flux botnet, and then we'll go over like the extent of the threat. We'll describe like the domains, the IPs, and we'll give some interesting stats on how we can track this threat.
Part 2 and 3 and 4 will be doing it by me, about the 10 minutes we have it. So analysis of the Kelios weaknesses, disclosure of the actors or the IDs, and then the stopping the payload distributions of the Kelios.
So this part, like we said, it's going to be the real-time monitoring system, and then we'll describe some of the data and the stats about it. So the system is, as you see it here, it's simple but pretty efficient. So basically, you start with a seed of domains that you know are matching the Kelios Fast Flux profile. And then what you do, you start resolving these domains since they have a TTL of 0, so then you'll get a different IP in every second. And then you continuously use your DNSDB, do inverse lookups to find any new domains that start mapping to these IPs. So you have like two components here, milking for IPs and then doing the reverse lookups to find new ones. And then that's not enough. You have to do some post-check processes where you have to detect domains that have that profile you're looking for. So you'll have to look for the TTL, the registration, the existence of the payload. In this case, it's the Kelios one. And then at the end, you add those new domains to your initial seed, and then the process goes again and again. So it's like a 24/7 process that goes endlessly catching every new domain. So now you might ask, how do we build this initial seed of domains to basically feed the process? So you can start with a blacklist that you get from third parties or that you have yourself. We started earlier with a machine learning based fast flux detection system. It was like random forest, and it was detecting like fast flux domains every day. And then from that we extract the ones we are interested in. So what you do, you start with that seed of like list of domains, you resolve them to IPs and TTLs and then name servers, and then you build a graph of the domain IP name servers, and then you are only interested in a specific TTL, because usually they're kind of having the same infrastructure or setting. So same TTL tend to be together. Not always, but what we do is basically build the graph, and then for each TTL equal X, we extract the largest component. So they're going to be linked via IP or name server. And this is pretty efficient here to basically extract either TTL 0, which is Kelios, or like some other botnets, like TTL 150 or 300 seconds or 1440, like it was described earlier this morning. So what is the Kelios profile, basically? So the Kelios domains have been using a variety of top-level domains, like generic ones and country code. Usually, like we said, they resolve to a single IP with a TTL of 0. They're hosted on the same IP pool. It's growing continuously. And then these are usually infected residential machines. The domains have a recent registration, just like the same day they start being used. And they deliver like malware samples with known names. And then we saw also some rare cases of Kelios domains with TTLs different than 0, like 600 or 300. But those are like very limited. Now, as we said, the post-discovery checks. So once you get those new domains you catch, you have to eliminate everything that is already sinkhole. You don't want to pollute your milking process with like sinkhole IPs. And then what you do, you exclude all of the domains that don't match that profile you're looking for. So in this case, if it has a higher TTL than the one you're looking for, or if it's not hosted on the same infrastructure. So in this case, we're usually looking at infected hosts. So if you see like some shared hosting providers or like some VPSs, then that must be some other threat that you're not interested in at this moment. And then again, sometimes we found some domains that we thought were Kelios, but they had like old registration, and they were like false positives. And then also, if they are not hosting the payload that we're looking for, then they're not the ones we are targeting here. Now let's look at some of the analysis and data. So as we know, Kilios is an info stealer, a spam botnet, and it has a peer-to-peer infrastructure with fallback Fast Flux CNC domains. Now, we took a sample of 900 domains. These are the ones that have been caught in the past 6 months. And then we look at the distribution of the top-level domains. So as most of you know, they abused the .ru up to August, when our team, Malware Must Die, took down like a big bulk of the .ru ones. And then after that, the Kilios gang, they started scanning like a big pool of TLDs. Like they use the .com, the NL, the .net. So through a registrar, they try to basically use everything they can. Now, the most abused the most abused registrars, in fact, are BizCN, Internet BS, and a few others. Rick will describe some more of those details later. Now, if we want to look now at the extent of the infection, like the geo-distribution of the botnet. So we take a sample of 40,000 plus alive IPs, and these were scattered across 99 countries. And we looked at these up to like the very first days of December. So this is basically a map. I had a link to the interactive map, but for some reason it's not working. I will put it in later in the PDF maybe, or online. But as you can see here, Ukraine is taking like the lion's share of infections. And then you have Russia and India. Exactly. So yeah, like as we said, Ukraine, Taiwan, Japan, Russia, and India. So it's basically an Asia infection here. But you got cases in the US and other, European countries. So it's like worldwide infection here. Now, another interesting fact is we tried to track the botnet's life cycle. So here we basically do a ping sweep every few minutes and see how the unique IPs, they keep growing, because we're getting like some new IPs every second. But then if you look at the live IPs, they're basically following like a daily cycle. So this is not requests. These are like the alive IPs at every moment. And you can see they follow like a peak. So the peak here is like the rush hours of the day. And then the valleys are the time when people just go to bed and switch off their machines. Now the other interesting thing is that this follows the Ukraine-Russia time zone. So the night time, the peak, the valley is basically when Russians and Ukrainians go to bed, and then the peak, and then it goes back when they go to work or they switch on their machines and they start browsing the web or doing whatever, and then it goes up at like 5 p.m. when they use their machines the most. And so this is kind of another evidence of the distribution that we showed earlier with the geo IP. Now this is the current stuff. So this is like the first days of December. Up to this moment, there's between 26,000 and 40,000 alive IPs in the botnet. So it's not nothing here. And you can see it goes up and down following the daily cycle here. So that's basically the extent of the threat here.
And we have the full list of these IP addresses in our logs.
Exactly. So another fact here, the OS distribution. So we take a sample of bots, basically, bot IPs, and we found that 85% of them are using Windows XP or Vista, and 1/3 of them, based on the Nmap fingerprinting, were running Windows XP Pocket PC. Now, here we look at the daily detected Kilios domains. So what you can take away from this slide is that these guys basically are provisioning domains or subdomains every day on a daily basis. So they're not tiring or getting exhausted. Basically, you see the blue and the red are basically either domains or subdomains. So some days they don't have enough new domains, so they will use like subdomains under the existing ones. And you can see also there were like some valleys there where sometimes they run out of domains. We were like too aggressive in reporting them and shutting them down. So this could be also a way to see that as the researchers or the team or other companies are trying to shut down these domains, we hit them, but then they come back. And sometimes they're like more active and aggressive in registering domains, so they might have like peaks in the utilization on a daily basis.
Which is good.
yeah, so it's like a fight. We win and they win. And so these are like some of the subdomains that have been used in the past months. So as you can see, they follow like, again, like a randomized third level domain.
No offense to Netherlands.
Yep. So now let's look at some statistics about the lifetime of the domains and the IPs. So again, when you see domains lasting for very little time, you might say, okay, we're too good at reporting them and sinkholing them or suspending them. If you see them living longer, it means somehow they were able to get them to live that long. So in fact, there were like some domains that lived for months, and I'll describe in the next slides. Then if you look at the IPs, if you see that some IPs are just living very short period of times, okay, maybe that's because, you know, it's like the rotation through IPs of dial-ups or residential connections. If you see them living for long, it means those are like some IPs that have been there like forever, and zombie IPs serving the botnet. So we saw like cases where these IPs were either residential or university IPs, and they last for such a long period of time. So taking a sample here, 712 domains. The X is basically the number of days, the lifetime in days, and then the Y is log scale number of domains. And then you can see here that there are a lot of domains that live a very short lifetime. But then you got a few on the right that lived like 50 days. And these were typically the ones that were serving as name servers. So there was like the case of Flousry.com. It lived for like almost 3 months, and it was serving as the name server that gives basically the authoritative records for the Kilios, regular domains. Now let's look at the IPs. So for the IPs, same story. We see on the left that we got a lot of IPs that have very short period of like lifetime, like a few hours or just 1 day. And again, it might be the rotation of the IPs of dial-up connections or residential DSL. But then we see a lot of IPs that live 20 days, 40 days, 60 days, 80 days. That's a lot, in fact. And yeah, I mean, they're there. And I guess the concerned parties should take action and clean these up, because they're being used continuously here. Yeah. So, like we said earlier, around 2,600 IPs lasted for 1 day, and a large number of them lasted for less than a day. So that's basically what we see here. Now, for the past 5 months, we collected like 110,000 unique IPs. Again, that's not indicative of the size, but the slides we showed here about the cycle, that gives you an idea about the extent of the infection. So keep in mind, between 26,000 and 40,000 living bots exist in the Kilios infrastructure. And in fact, when we check them out, we found that around 11,600 IPs have hosted domains that have been serving. All right, so now I give it back to Rick.
Thank you, Dhia, for the time. Well, this is a time about some codes. First, if you see the infection of the Kilios itself, I will gonna explain about the infection started, and then go step by step into the what we can get it, and then see the weaknesses of it and use it, and then in the end we nail the bad actors' IDs. This is steps. Well, it goes by the campaign from the spam. This is what you know about the Texas explosion in the Waco's, kind of here. It's coming from the RedKit, actually. Was about a while ago. This is the kind of the files was dropped. The first one is HTML, contains the infectors, then the exploiters, and then go through it. We have the drops of the binaries all over places. First one is you can see right there is a capture traffic of the Trojans. This one is a downloader. Well, another downloader over there, and then and finally they are downloading this mess. Is a Kilios botnet binaries itself, which is drops, and they are also having another replacement of the binaries and install in your systems. Well, this is the collections, and then I go through it. This is the processes. If you run it, I'm not going to bore you with this. You know better, perhaps. And then this is the garbage you can see in the temp. And this is how the things are started. Well, it was requesting to the HTTP protocols over there, and then asking for something. We'll see. This is the kind of the POCs that they are downloading the Kellyhost. We call it Kellyhost Mama. In this case, is newpost3.exe, and there are so many files about that. We can explain about that later. Well, there is another domains over there downloading the same stuff. This is only the data of the same session of the infections over here. And we can see it there after everything settled and you are being infected. The post requests were sent, and then the reply will be a status import OK over there, down there. This is the one that the Kellyhost, the botnet, knows exactly that this campaign hit one spot. There's not only one in the one infection session. We see a lot of the access over there. Well, they are searching, and mostly up to the 255 nodes are searched in the one binary of the Kellyhost. It has a limit. Well, after that, we'll see the very impressive traffics going on, which are encrypted. We don't know what this mean by the text while we're seeing the files. And sometimes look like this. And what exactly is the Fortinet, Mr. Kyle Young was explaining pretty details about this traffic details, and that works until now. Okay, this is the mapping that has to be used to decrypt the Kellyhost traffic. And what you have to do, if you decrypt it well, right now the current configurations of Blowfish, RC4, Blowfish, same key sections, and you'll get this information over here, which is leading you to the domains and the payload names. That is the one that we have shoot after in the Kellyhost. Well, the logic is like this. We put it into the regex. Well, you can say, do you have any mic that I can wear? Okay. So this combination is pretty simple. They put everything into 11 bytes for the domains or the payloads. Simple. See, like this. This is a regex of the 3 possibilities. 6 with dot, go to the 4, and then 7 with dot, go to the 3. 8 with dot, go to 2. Total is 11 bytes. POC. The domains, you can count it, 11 bytes. The payloads, also 11 bytes. It's quite the same, quite very simple logic. And if you make the statistic of the payload itself, not so many modifications, none of it, except this special customer there. Like Dhia already told you before that the botnet is using many stuff, but the most important thing is a botnet as a service for the Kellyhost. These are probably customer and their own domain. We don't know it. Okay, go forward. Well, the detection rates of the Kellyhost binary itself, for the popular one, we spot it a lot. It has a bigger detection rates, yes, but mostly these commercial ones, which belongs to the customers of this botnet itself, has a lower parts, like that. I cannot see the new binary of the Kellyhost was detected more than 10 in the virus total. I'm not going to argue with the antivirus offices about this. The domains, like Dhia mentions, these are the domain registrar being abused by the Kellyhost. Well, you can define by your own, but BCN, Internet BS, PDR1 API is in Germany. Regi and Regtime are in Russia in these cases. So Internet BS we handle pretty well with the help of the ICANN. BCN we got so hard times, and then finally we just nuke them down, about the 300 more. And if you want to see it, what Kellyhost was infected, I put it in the virus total actually with these regex. It will be shared, so you can trace it later on. Next, this is why we can detect the new infections domain actually. You don't have to crack the CNC and job servers communications in this case, but you can see it by the OpenDNS tools, for example. This is when the domain was starting. It has a pretty good graphical tools over there, so you can see it was starting over there. This one is starting and not being closed until pretty long time, for example. So we make a good observation by that. Comparing those encryptions data and with detection through the OpenDNS tools, we create the alert. Alert goes like this. I'm sorry, I sent it to the Roman over there. This is the one of the alert. Once the alert sent, the domains will be sinkhole, done. But you know, like Dhia said before, it will come up again and again. So why? You want to play whack in mole? No. We want them to register as much as possible for the evidence collecting purpose. We want to know the ID. We want to nail them. We want to put them into jail. We want to stop this. So here we go. Full disclosure of the actors and ID. Eric, there will be no online in this, right? Okay. This is This is email addresses that they are using for those domains. I just would put the blog about the 2000s domains related to the many exploit kits and so on. This belongs to number one only, 2,800 something. All bad domains, and we have 4 of them. You just times it, and then you will figure it out. This is the one. You can make a notes, you can make a picture. I give you, okay, enough time. Then this is why we can know it, because of a PDR registry has a pretty good data recording about those stuff. This is the one that we saw. Are these the real email addresses? No, this is not, because of you know, like Mr. Silik Andre is a very well-known bad guys living in the Belarus, which is not related to the Kelly host at all, but they are using another criminal's name in this case is to what? We're not that fool, okay? But using those kind of the addresses, we know exactly where they are shopping the domain. This is a domain shop. Some of you know this, and these are the description of the domain that being put into internet. Don't ask me how I get it. Picture? No? Okay, next. This is how they are making the spam. This is their email address. They are asking to the Mr. makeawismail.ru. Make this kind of the spam contents. And a day after this, the spam coming. Exactly the same contents. Well, we don't believe it. Try again, wait, different dates. This is the header of the order that they are making. This is the template. As a result, this is the spam. Same one. See? Apple goes fucked up, so you have to buy the stocks, stuff like that. So, this is a pump and dump kind of a spam. Okay, go next. We have this email address before, yeah? Silik Andre. All we have to do is compare them to every forum databases that exist. So, unfortunately, I have in my hand some SQL dam, and then one of them match. In this case, what we can learn, we know about this nickname. This draw line is hanging around in many forums, including dark codes. Picture? No? We have this informations, and then now all we have to do is get into the CNC. And here we are in the CNC. We know what's inside. We have it. This is the one. Okay, we catch the flags. Move on. Oh, picture? Oh, no, this one, picture. Once upon a time, our friend Caffeine was putting into their blogs there about the cookie bomb iframe way. It was said Tales of the North. In the end of the message, it has the contact information like this. And please contact me with a name, whatever, within this domain, in that message. That every record of this domain, it's this IP address, which link to this one of the CNCs over there. Meaning, you guess. And there are more, like this. I cannot show you more. All of them are, this is a TDS that they are using. Different business. Same actor. And this is the bad actors. You got 2 seconds.
This is the guy.
This is the guy. Russian. 37 years old. Not being catched, not being arrested until now. I was cracking this from the September and waiting for the result until now. The deal is we have to say this. It's supposed to be arrested before BotConf. They don't do the job, so exposure. Next. What is the efficient way to neutralize the Kelly host? There are very good persons, good individuals, good entities are taking down the Kelly host. But why it came up again? Face it, you cannot shut down the botnet because it's used the peer of the infected PCs. Can you shut down the infected PCs in your country? Nobody can. I saw only Netherlands, Deutschland can. Because of the infection is 1, 2, they shut it down, 1 and 2. But I have in Japan, no, we have thousands now. In Russia, they are giving up. Too many of them. In United States, right now it's about the 150s. And I saw some from the United States over here. It's already in the DOD, it's already in the FBI, but I don't know. I didn't get the response or whatsoever, but the infection is still there. Then, stopping the peer is not the question. Let's stop the payload then. It's very good. We know the payload, yeah? Like before I explained, the domains, the binary names. And they are actually in our, we are creating our monitoring under IRCs, which having where I separated into some countries over there. And we just pop up the URL, make a sample of the one, generate sample that can be clicked to be proven that you are downloading some, not good stuff. And then it's supposed to be running like this. Then we shut down the CNCs in the Deutschland and Netherlands. And what happened next is this. It happens 4 days. And then this. No data. It means we can shut down their payloads. It's smarter. Why taking down all of the botnets then? This is the know-how to do it. Then, another one, connection reset back here. This is the way that we are, as a malware master, would like to share. You don't stop the botnet by killing the peers. No way. It's too many big stuff that you are handling. But you can, be smarter than that. Be smarter than these guys doing this, for example, an idea. Well, the summary.
So yeah, like Rick said, we have to cut it from the root. So as a summary, as a team, we're dedicated trying to do good stuff on the internet, make it cleaner for people. So basically the study was showing the real-time monitoring system. We also look at the daily zone files and apply the regexes Rick described to catch GNU domains. that sometimes did not appear in the traffic, because again, the monitoring system relies on the DNS traffic. So if they haven't triggered traffic yet, then you cannot see them. So then you have to combine that with like use zone files and apply regexes. Once you identify some of them, you go and check for the profile that we described earlier. So it's kind of a combination of techniques here. And then we do the malware payload analysis that we described. And then the important part is report the domains to the appropriate bodies, registrars, the ICANN, so they can suspend them or sinkhole them. And then report the IPs to the ISPs, the regional certs, and of course to law enforcement, because again, we can run after these guys, but if we don't arrest them and put them into jail, then this can continue forever. So basically, this is an appeal for all of you, all of the community, to work together for shutting down this plague.
Okay. In additional, we are sending emails about our findings in the regular basis. If you don't receive anything from the malware study from now until now, just hand us the email addresses, so we can share you everything we got in the email, not in the public. They are pretty interesting stuff over there. And all of the work is not done by the individuals. We are as a team. Team are breakdown into pretty segments like this, and I don't want this to be into internet at all. So thank you to these guys who's working pretty hard day and night. And some of these guys are here with us today, which I really, really appreciate your being here. So,
we applaud you.
Thank you very much. Any questions?
Questions?
The applause was for you, not for us.
No questions? You're like startled? Yeah.
Hello, Dimitrios. One question, guys. You published online a small portion of this, almost 3,000 domains, right? But could you share it by email, as you mentioned, the complete list of the domains, like 3,000?
Yeah, certainly, yes.
Awesome.
We're actually sharing that, but there are so many people to be shared. So if you're not receiving anything until now, give us your email address.
Another question? Okay. Thank you very much.
Thank you so much.